Have you ever opened a massive, messy spreadsheet and just felt that wave of dread wash over you? Yeah, we've all been there. Well, if that's you, you're in exactly the right place. Today, we're going to demystify a process called database normalization. And I know, it sounds super technical, but trust me, it's the secret to turning that data chaos into a clean, powerful, and totally reliable system. So let's get into it.
So here's our game plan. First, we're going to investigate the crime scene. We'll see what happens when good data just goes bad. Then, we'll bring in the hero of our story, normalization, the cleanup crew. After that, we'll get our hands dirty with the 3 core steps to get our data whipped into shape. And finally, we'll get to the best part, the incredible benefits you get from all this hard work.
All right, time to put on our detective hats. We're starting at the scene of the crime, where we're going to uncover all the hidden dangers that are just lurking inside messy, unorganized data.
Okay, so take a look at this table. At first glance, it looks harmless, right? You've got students, their advisors, the classes they're taking. Seems straightforward. But what if I told you that this simple-looking table is actually a data minefield just waiting to explode? Let me show you exactly what I mean. These hidden dangers have a name. They're called data anomalies. And make no mistake, these are the absolute villains of our story. They're these weird glitches and errors that creep into your data, and they happen for one reason. You're storing the same piece of information over and over again. And that turns simple tasks like adding or deleting something into a total gamble.
So meet villain number 1, the insertion anomaly. Let's say you want to add a new bank branch, Round Hill, to your system. With this table structure, you can't. It's impossible. Why? Because the table says you have to have an account number to create a new row. So the system itself is physically stopping you from adding perfectly good information. It makes no sense.
Next up is the update anomaly. And this one is just a recipe for disaster. Take a look at employee 519. Let's say they move. To update their address, you have to find and change every single record where they appear. And what happens if you miss one? And let's be honest, it's so easy to miss one. Well, now your data is inconsistent. You have 2 different addresses for the same person. You can't trust it anymore.
And our final villain is the sneakiest of them all, the deletion anomaly. Check this out. Dr. Giddens is the only person who teaches the course ENG 206. Now, if Dr. Giddens retires and you delete that record, poof, you've just wiped the entire course ENG 206 from existence in your database. All that information is just gone, simply because it was tied to one person. That's a huge problem.
So, we've seen the mess, we've met the villains. It's pretty clear that things are out of control. Now it's time to bring in the hero. This is where normalization steps in. Think of it as the ultimate cleanup crew, designed specifically to bring order to this data chaos. So, what is normalization really? It's not just about tidying things up a bit. It's a formal, step-by-step process for organizing your database. The whole point, the main goal, is to hunt down and get rid of all that duplicated data we saw causing problems. When you do that, you automatically improve the integrity, the trustworthiness of your entire system. And when you look at these goals, you can see they're a direct counterattack to those anomalies we just talked about. By getting rid of redundant data, you basically starve those anomalies. They can't survive anymore. And what you're left with is a database that's way more efficient, way easier to take care of, and totally ready to grow.
Okay, so how do we actually do this? Well, it's not just one magic button. It's more like a journey through a series of stages called normal forms. You can think of them like levels in a video game. We're going to walk through the first 3 because they're really the most important ones you need to know.
Our journey to clean data follows this path right here. We start with the first normal form, or 1NF. Once we've got that locked down, we can move on to 2NF, and then finally to 3NF. Each step builds right on top of the last one, so you have to do them in order.
First up, first normal form, 1F. The rule here is beautiful and simple. Every single cell in your table can only hold one single piece of information. It has to be atomic. So on the left, you see the knowledge column is breaking this rule by stuffing a bunch of skills into one cell. The fix, on the right, is just to break them out. Give each skill its own row. That's it. We are now in first normal form. Next, we level up to second normal form. Now, this one's a little bit more about making sure your data's living in the right home. Here, the course name only really cares about the course ID. It has nothing to do with the student number. When a piece of info only depends on part of a key like that, we call it a partial dependency. And the fix? We give the course its own table, its own home where it actually belongs. We split them up so that every piece of data fully depends on the key in its own table.
And our final big step is third normal form. This is all about cutting out the middleman. It tackles something called a transitive dependency. In this table, to find the department head, you have to go through the department name first. The head depends on the department, not directly on the employee ID. That's an indirect link. So the 3NF solution is, you guessed it, create another separate table just for departments. Now everything in the employee table depends only and directly on the employee ID. Okay, we've done the work. We've climbed the mountain, followed the rules, and organized our data. So, was it all worth it? Let's talk about the payoff, the incredible benefits of having a clean, normalized database. I mean, this slide just says it all, doesn't it? On the left, you have that one giant, complicated, messy table with data repeated all over the place. And on the right, after we've worked our magic, 3 clean, efficient, interconnected tables. Each one has a single job, and it does it perfectly. This is the perfect picture of going from total chaos to crystal clarity. So what does this all mean for you in the real world? Well, data integrity means you can finally trust your data again. Eliminating redundancy means you're not wasting space or risking errors. Your searches and reports will run faster, and maintenance, it becomes 1,000 times easier. But maybe most importantly, your system is now built on a solid foundation, ready to grow as big as you need it to without breaking. If you only remember one thing from all of this, let it be this mantra. Say it with me. Everything must depend upon the key, the entire key, and nothing but the key. This one sentence perfectly sums up the entire philosophy of normalization. It really is the golden rule of good database design. So we've taken this journey from a complete data mess to a clean, reliable, and powerful system. But this new clarity, it isn't just about preventing bad things from happening. It's about creating new opportunities. It lets you ask questions and find insights that were literally impossible to see in the chaos before. So I'll leave you with this to chew on. Now that your data is organized, what new, powerful questions are you finally going to be able to ask it?